Welcome to another Mr. Ball video. Today we are on 3.1 volume of a cylinder. In this video, we're not talking about the conceptual this time. We're talking about how to actually calculate how much a cylinder can hold, meaning what is its volume. If you're not sure what we mean by radius, by volume, please look at the previous video and it'll talk more conceptually about what does it mean to be a cylinder, what are we talking about when we ask for volume. In this video, we're talking specific examples, how we can get the amount so something can hold in a cylinder. Okay, so I just want to remind us from the last video some important things about cylinders. Okay, so this is an example of a cylinder. It looks like a pop can, like a soda can. It looks like a can of beans or green beans. When we're talking about a cylinder, remember it's like a stack of circles. Halfway across the circle, halfway across the top, is going to be called the radius. It's halfway across the circle side. And it doesn't matter where it is. It's not necessarily on the top. It's anywhere. But it is halfway across the circle. Remember, these are a stack of circles. The diameter is all the way across. Okay, it's the distance that's all the way. So radius is halfway. The diameter is all the way. And the height is how tall is my cylinder? How tall is my Coke can? How tall is my can of beans? And this is important because there's only three pieces of information that we could possibly get. So we can think of it as one radius is half of the diameter, meaning this radius is half of the distance of the diameter. Or we can think about it, if I put two radiuses together end to end, it'll be worth the size of just one diameter. So if I was to say this is one radius and then continue it again, that would be two radiuses equal to one diameter. And this is important depending on what the problem is giving us. So for example, this is a type of cylinder and they're giving us some given information. And I want to find the volume. Okay, so we are going to find the volume. Okay, the volume of this shape is a cylinder. So I get to use the formula V equals pi r squared h. So let's start there. V equals pi r squared h. Now, before we start just plugging stuff in, let's remind ourselves what V, pi, r, all that stuff is. So remember V meant, hey, this is the volume. Okay, pi was a symbol for a number that goes on forever. But just because it goes on forever doesn't mean we don't know what it is. We can approximate it, and that approximation is never going to change. This is 3.14. If I don't like dealing with the pi symbol, I can just replace it with 3.14. The R stands for radius, and the H stands for height. Now, it's my job to determine what information am I given to be able to solve for what the volume is. Well, let's take a look. In this particular example, I'm given 16, and it's the distance from the top to the bottom. Oh, okay, that is my height. So the height, I can think of this as the number 16. This is equal to the height. Well, I'm also given another number. This is halfway across the top of this top circle. If it's going halfway, I know that that is actually my radius. Now, r is my radius. So I can think of this number r as 6.5. Whenever I see this symbol, I know that it's just a number. Okay, the decimals go on forever, but the approximation doesn't. The approximation stays the same. Whenever I see this symbol, I can replace it with 3.14. And that's equal to, and this is all of the known information that I have. I don't have any other information. So this volume can be calculated as, I'm just going to rewrite this equation, but with the known numbers in. So instead of pi, I'm going to write 3.14. So I'm going to say 3.14. And then it's times the radius squared. Now the radius was 6.5. And I'm going to square it. And then the height is 16. So I'm going to multiply that by 16. You'll notice that it's a number times another number, which is being squared, times another number. I like to deal with the exponents first, but I know what 6.5 squared is. So let's one extra step here. V equals 3.14. That's staying the same. And this is just 6.5 times 6.5. And that's also times 16. All I've done in this step is put it visually so you can see what's going on. 3.14 times 6.5 times 6.5. These two 6.5s came from this 6.5 squared. Remember, that's 6.5 times 6.5. And then times that by 16. We don't expect you to do this by hand. You are given a calculator, and I expect you to be able to use it. So we can calculate the volume by multiplying 3.14 times 6.5 times 6.5 times 16. So in my calculator, I'm going to go 3.14 times 6.5 times 6.5 times 16 equals. I come to a total of 2126.64. B equals 2122.64. If you'll notice, that's what it says on my calculator. When I multiplied 3.14 times 6.5 times 6.5 times 16, this is your volume. This is your volume. Now, where could some common mistakes be? Let's just be clear. We have to first identify what it is giving us. Okay, that's the first step. We have to know what information is given. And we're going to see why this is important in the next couple of examples. So let's do another example and see how much this changes and how much this stays the same. So let's suppose I erase this number here and this number here. I'm going to give another example that looks like another cylinder standing up. But instead, I'm going to give us some different information. So suppose in this one, I'm not giving us the distance all the way across, halfway across. I'm giving it all the way, and I'm going to say that that's 4. I'm also going to say that this distance is 3. Now, we're going to start with what's the volume. Okay, so this is V equals pi r squared h. I can fill in some information that I know. For example, 3 is the height. Okay, so this is a 3. The pi is equal to 3.14. Okay, now when I get to radius, remember I don't want to use 4 because the 4 is the distance all the way across. So 4 is equal to the distance all the way across. That's the diameter. And my formula doesn't ask for a diameter, it asks for a radius. So I just have to remember, one diameter is worth 2 radius. Or I could think of it if I half the diameter. So I need half of this amount. Remember, my formula asks for the radius, which is half of the diameter. So I'm going to take this number and take it in half, and that will be equal to my radius. So half of 4 is 2. Okay? 2 radiuses make up the diameter. So this r is going to be a 2. Let's rewrite this equation. V equals 3.14 times 2 squared times 2 squared times 3. Okay? In this particular example, I was given a diameter instead of a radius. A very common mistake is to grab that number and put it in, but remember your formula asks for a radius. Make sure that you're not given a radius or a diameter. Okay, well, I will multiply this out first just so I can put it in my calculator easier. So 3.14, and that's times 2 times 2. This is just 2 squared, so 2 times 2, so 2 times 2, and then times 3. Now I just grab my calculator, and I'm going to type in 3.14 times 2 times 2 times 3 equals 37.86. 37.86. Excuse me, 37.68. 37.68. So V equals 37.68. Okay, that's it for today's video. There are a couple more examples which we can discuss in class, like if I was to take this and turn it on its side, similar in a way that I had my poker chips sitting this way or sitting this way. The height would still be on this side versus it'll be here. So I don't feel like adding that to this video. It should still, do know that you're not being confused. It's still the same information. The circles are just on the endpoints instead of on the top and the bottom. That's all for today's video. I hope these examples help. Peace.